across Newfoundland and Labrador, throughout Canada, and around the world need effective and affordable ways to treat wastewater in order to prevent harmful human disease and to protect the environment, including fish and wildlife. But rural communities are frequently challenged to provide sufficient financial and human resources to meet that need. Fortunately, there are solutions. One of them is all natural, cost-effective, requires little or no maintenance, and best of all, performs with excellent results in treating wastewater. The resource that makes it all possible, well, I'm standing on it. It's peat. And it's a gift from nature. Peatlands are wet ecosystems that contain a surface layer of peat. Peat forms when partially decomposed plant material accumulates. A peatland is water-saturated and lacks oxygen, which is why the dead plants in a peatland decompose very slowly. New plant matter accumulates faster than the decay, so the peat layer grows gradually, less than 1 millimeter of new peat accumulating per year. It can take thousands of years to form a thick layer of peat. Peatlands are found in 180 countries and cover approximately 3% of the land and freshwater surface on Earth. More than 90% of the world's peatlands are found in the Northern Hemisphere. There are large concentrations in Canada, Alaska, Northern Europe, and Siberia. In Newfoundland and Labrador, peatlands are a common part of the landscape and are found throughout the entire province. Here, the most common form of peatland is the bog. It forms in a poorly drained area. The water in a bog is acidic, low in oxygen, and it originates from rain, snow, and other forms of precipitation. Here we find plants such as sphagnum mosses, ericaceous shrubs, and reindeer or caribou lichens. The bog contains many specialized plants, such as pitcher plant, the provincial flower of Newfoundland and Labrador.
Usually these come out in early summer, and it must have been fooled by the day length into flowering again.
Michael Brzezinski is an ecosystem scientist with Parks Canada at Grossmorn National Park.
A bog is a wetland dominated by sphagnum moss, and sphagnum moss, this is a little bit of it here. There are many different species that live in bogs here, and some of them in very, very wet sites, some of them in the drier tussocks, but they all act pretty well the same way. They don't have roots, they don't have true leaves, they don't produce flowers, and they essentially pickle their older parts, their older stems and leaves by producing this acid. The cold, wet, acidic soil stops decay from occurring further down in the bog. So as the bog grows upwards, the lower parts get preserved, and the structure, the wick-like structure of the stems and leaves of the sphagnum actually wick the water table up with it. So as they grow, they actually pull the water table higher and higher, eventually raising the bog above the surrounding landscape. The bog is so saturated with water, there's so much water in this peat that we're actually literally standing on water. It's almost like standing on a lake. And you can, by shaking, jumping up and down slightly on the bog, you can get the whole thing quaking. You can feel the whole bog around you actually moving. You can see the reflections on the water on the pond over there, just sort of jiggering back and forth as we shake the bog, just by jumping up and down on top of it. Strange things to be doing in the bog. What I'm going to show you is just how soft the wetland is and how it differs from mineral soil, a regular mineral soil. This is just moss and peat, and it's so soft you can actually drive your arm right down into the soil, right up to the elbow, well, past the elbow. It's just solid vegetation. As I say, about 3 different species of bladderworts here.
Is this the bladderwort?
That's the one that
Peatlands provide important habitats for wildlife and help to maintain a diversity of species. They also perform valuable ecosystem services, such as regulating water flow, maintaining water quality, and storing as much as 1/3 of the world's carbon found in soils. Around the world, people use peatland areas for many purposes, such as for agriculture, livestock grazing, forestry, and crop production. Peat is also harvested as a resource. In Europe, people use peat to supply energy needs, particularly in rural areas. In North America, we use peat to improve soils and as a substrate in horticulture. People also use peat for the containment of oil spills and contaminants, and as bedding material or litter for livestock. Peat is used by the pharmaceutical and cosmetic industries as an ingredient in many products. It is even used in the malting process to enhance the flavor of whiskey. Aboriginal peoples used the disinfectant and water-absorbing properties of sphagnum peat to treat wounds and to create diapers for their infants. So it is no surprise that researchers have found peat to be a very effective medium for treating wastewater. Communities everywhere seek low-cost solutions to the challenges of sewage treatment and disposal. They know that there are risks associated with untreated sewage and that it should not be disposed into rivers and roadside ditches. One potential danger posed by such practices is that people might be exposed to harmful bacteria such as E. coli. Even the more common practice of discharging raw sewage into coastal waters is now coming under scrutiny for environmental reasons. The sphagnum peat found in bogs of Newfoundland and Labrador is particularly suited for treatment systems in cold climates. While some other systems may go dormant or fail in freezing temperatures, the peat keeps the system warm. This enables the microorganisms to feed all winter long. The beneficial properties of peat influenced the decision to approach engineer Dennis Martin about designing an all-natural wastewater treatment system suitable for the climate of southern Labrador. With the cooperation of the Province of Newfoundland and Labrador, the Quebec Labrador Foundation, the Town of Forto, staff and students at Mountain Field Academy, and with a generous grant from the EJLB Foundation, the province's first peat filter wastewater treatment system was constructed in 2001 in Forto, Labrador, using Dennis Martin's design. Since 2001, the system has never failed. It has not needed any maintenance. Dennis Martin has been working with sphagnum peat as a wastewater treatment medium for over 20 years. His early research was focused on finding a solution to a serious problem of drinking water contamination at schools. He introduced the first peat filter wastewater treatment system in Canada, based on earlier work by researchers at the University of Maine. Since then, he has applied the peat filter technology to numerous projects across Canada.
One of the things that intrigued me most was the fact that 1.5 feet of peat was removing bacteria and dangerous organisms down to 0 levels, equivalent to what would be safe for drinking. It's basically been consistently performing beyond any mechanical plant that we know of that is anywhere near as simple as running effluent through a layer of soil, which is peat. This project is basically for a subdivision that's going to include about 567 homes. Many homes are now built, and it's an ideal site to show because it shows the different stages of construction. We have a completed system at the far end, a partially completed system in the middle, and a system just starting to be constructed at this side. And as you can see, my footprints are very evident. It's actually not quite at the right compaction. When I walk on it, it compresses, and I'm sinking less and less. Just from experience, this is about the ideal compaction right here. I sink in about 1/2 inch to 1 inch, basically compacted with people on snowshoes is the first approach developed.
Wastewater, including raw sewage, flows from the building to the septic tank, where solids are removed, then on to the peat filter system. As the wastewater descends through the filter, it is absorbed in thin layers by the tiny granules of peat. The fungal organisms living in the peat purify the wastewater that contains harmful bacteria. Eventually, the wastewater reaches the bottom of the peat filter, where it either collects into a trough and is channeled to a point of discharge, or it enters the soil and reaches the water table. Peat is very effective at removing ammonia, which is a serious concern for salmon and trout. Western Brook Pond is a spectacular fjord in Grossmorn National Park. Its main trail and pavilion receive an average of 27,000 visitors each year, most of them concentrated into a short summer season. Jim French is the asset management engineer with Parks Canada, who led the effort to select an appropriate wastewater system at Western Brook Pond. Eventually, they chose a peat system designed with the help of Dennis Martin.
The old conventional systems processed only about 1/4 of what the capacity of the peat can do. So we ended up with a smaller footprint. It was easier to construct. It could be constructed by normal labor using small equipment. So it made the feasibility and cost actually much, much better than if we had used more conventional processes. Peat retains about 8 times its own weight in moisture. It allows for a long processing time, so you get both aerobic action from air percolating down into the filter. You get biological fungal action, which is unique to peat and is very good at processing. And then you get the third anaerobic process at the bottom of the filter where there's no air. You get an anaerobic process that goes on. So when the water passes through the peat, it has been processed. It removes almost 100% suspended solids. It removes like 98% biological oxygen demand, BOD, what we call BOD, 80 to 90% of nitrates. It removes phosphates. We've actually done testing on it. E. coli coming out of here, because you're dealing with a very concentrated effluent coming from the pond, because again, there's no showers, there's no bathing or any of that thing. It's a very concentrated effluent. E. coli in this chamber here are greater than 500,000 per 100 milliliters of water. And we've tested at the bottom of the filter, and in one we had 1 E. coli, and the other one we had no E. coli. So its ability to remove bacteria is phenomenal. And it's such a passive system that, once you build it, you just basically let it flow to the filter, and what comes off of the bottom of the filter could be used in a swimming pool. Basically, we looked at it, it would meet the swimming pool criteria. And in actual fact, the research and the operation of peat filters in the north have indicated the fungal action actually speeds up with colder temperatures. So they actually get just as good a processing in colder temperatures. It's a completely natural product. We had trouble keeping the moose out of it. The moose just used to love to come up and lie on it. They like the nice soft peat.
And sphagnum moss basically grows in shallow depressions.
Each year, park interpreter David Morrow leads visitors on interpretive walks through the peatlands of Grossmorn National Park.
You can actually see the remains of the sphagnum moss here. And this essentially, because sphagnum moss has a lot of hollow cells to hold lots of water. So just watch. I'll take this handful of peat and I'll squeeze it, and look at all the water that comes out of it. So what I have here is a filter that's kind of demonstrating the principle of how our peat moss septic leach field works. So I've deliberately taken some moss from the forest floor because the dirty water will go through this fairly quickly, but if we were using the real sphagnum moss, it would actually take more than 24 hours for it to go through the filter. So what I've got here is a bottle of nice muddy water to sort of simulate the liquid effluent coming off the septic tank that would be going to our peat moss septic leach field. And I'm going to pour this in, and you'll see that it'll sort of hold up in the filter and it'll start dripping through, but it's going to take a while for it to all go through. What you'll see is it'll filter out the mud, and the water that comes out will be virtually crystal clear.
In 2005, 2 more peat filter systems were installed for a cluster of homes in the English Point area of Forto, Labrador. This time, bales of compacted peat, wrapped in burlap, were stacked tightly in rows and the piping placed on the top layer. 2 of the homeowners who were sharing a peat system chose to landscape the surface as an extension of their front lawn. The students at Mountain Field Academy in Forto believe that people need to understand about wastewater treatment and to act responsibly.
The whole country is really getting, educated about this, and we're really trying to push it. There's a lot happening in our world with our environment. We need to find a way basically to just help this situation. Already 3 spots in this small rural community in Labrador have already started, so hopefully that'll spread not only throughout the province, not only throughout the country, but throughout the whole world, because it is a really good thing.
Mayor Tom O'Brien of Stephenville recognizes the added benefit that proper wastewater treatment brings to the economic sustainability of communities.
Oh yes, there's no question. The peat resource for the wastewater system, it's very intriguing. I can see how it would work, and certainly it provides another alternative for communities, small, medium and large, to look at to get into the wastewater management systems. We need to put things in motion now in order for us to accomplish the goal, which is to protect our environment. Each day that we waste, that's 1 more day's damage done to the environment. And at the end of the day, when you accomplish it, you will feel good, your children will feel good, and your grandchildren will be saying thank you.
Business leaders, especially in Newfoundland and Labrador's hospitality industry, are insisting that striving for improved standards for environmental sustainability will attract more clientele to the province and be good for business.
Newfoundland is a pristine environment. It needs to remain pristine. And if we're going to change rural Newfoundland, we have to have this available to us. And without this, we're back where we were 50 years ago, and that's no good.
It's proven that it can work. I think that, we're obviously still studying some of the aspects of it, but I think it is proven beyond, any reasonable doubt that this system can work in this climate. And in my view now, it all comes down to dollars and cents. And as a businessman who's been involved with worrying about dollars and cents, this is very cost effective.
It has taken thousands of years for the vast peatlands of Newfoundland and Labrador to develop. They perform vital ecological services that benefit global as well as local needs. They also provide important habitat for wildlife and help maintain the diversity of species.
A lot of people miss the beauty of the bogs, the color, the texture, the variety of plant life here, and the really fascinating smaller things that go on in the bog, those insect-eating plants, those orchids, just the way that the sphagnum itself actually lives and produces this organic ecosystem that surrounds us. That's what I find most beautiful about the bog.
Peat continues to accumulate in peatlands around the world. It can be harvested responsibly using the most ecologically sustainable techniques. These minimize the release of greenhouse gases and encourage the regrowth of the surface layer of vegetation. If we are careful about how and where we harvest, and if we make restoration part of the overall plan, on a large scale, our use of peat can be sustainable. Peat is a gift from nature. We must use it wisely.